Welcome to my channel RLD Academy. In this video, I am going to discuss one gate problem on two-port networks. So this is tutorial number 1. And this problem is from GATE 2021 ECE. Now you look at the figure. Here it says that it is two-port network. So this figure looks like a pi network. Okay. So one element is 1 ohm here it is 1 ohm, here it is 1 ohm. But with this pi network, one more element is connected here. That is one dependent source, dependent current source. It is depending on this voltage V2. So its value is 3 V2. So it is voltage dependent current source is connected here. So we need to find out the admittance parameters, the Y parameters for this circuit. Okay, so you know that for Y parameter we'll use this one. So this I1, I2 will express I1 and I2 in terms of V1 and V2. Okay, so this is Y11 V1 plus Y12 V2, and for I2 it is Y21 V1 and Y22 V2. So if you can express this I1, I2 in terms of V1, V2, then from this equation we can equate these parameters Y11, Y12, Y21, Y22, then we'll get the result, right? So we'll derive this, we'll consider this I1, I2, and then we'll find out this exact value Y11, 12, and Y21, Y22, right? Now before that, in my previous lectures, we have shown that for pi network, we can easily find out the admittance parameters, and that is very easy. Okay, so if this is your pi network, so except that dependent source, if I don't consider dependent source right now, okay, so this is your V1, this is I1, this is V2, and this one is I2. Just think it carefully what I'm saying. So this is your 1 ohm, this is 1 ohm, and this is given 1 ohm. So Y parameter for this network can be calculated very quickly, that one discussed in previous lectures. So what you'll do, the first element Y11, that is the input impedance under short circuit condition, that is your this, considering these two only, its admittance plus this admittance. Its admittance is 1 upon 1, 1 more, this also 1 more. So 1 more plus 1 more is 2 more. Okay, so this is your 2. Similarly, the output impedance, again it is symmetrical, no? So this is again 2. Now this one, this Y12 and Y21, these are transfer admittance, and those are with respect to this middle one. Middle one more is 1 more, so negative sign of that, so minus 1 more, it is also minus 1 more. So it is fully resistive, thus it is reciprocal, and if it is reciprocal, resistive one, then Y12 should be equals to Y21 for resistive circuit, for reciprocal I can say. Okay. Now if there is no dependent source, only resistances, then obviously it is a reciprocal network, and that time you will get Y12 equal to Y21. Now in this case, the circuit is having one dependent source. So because of this, you may get the non-reciprocal network. So these two could be different. Okay, that is one thing we can conclude. And Now this input impedance and input admittance, output admittance, that we can check a little bit carefully. So for this networks, I'll give you some hints that how quickly you can choose this out of this four choice one you can choose it. Okay, now what you will do, so this is 2 2 minus 1 fine. Now here if you look at this one, can you find input impedance quickly? So input admittance means, so V2 is sorted. If you sort it, this one, this end, there's no effect of this 1 ohm resistance, so it is sorted. Okay, then you will find out the admittance from this side, right? So if it is sorted, this V2 is sorted. If V2 is sorted, this current is also 0 because 3 times V2. So if V2 is sorted means V2 is 0, this current is not there. That means only this 1 ohm and 1 ohm will be there. So like a simple pi network. That means your input admittance will remain 2. It will not change. Right? Again, if you consider the output admittance, in that time V1 will be sorted. If V1 is sorted, then any element with the short circuit element will not affect in this circuit. Okay, so we can ignore all those things. So this dependent source will not have any effect on this output admittance, short circuit output admittance. So it will remain again like a pi network. That means it is 2 again. So input admittance 2 and output admittance is also remain 2. Okay. So only thing is that these two we need to find out. And now, so here A and C both will have same condition. So Y1 1, Y2 2 both are 2 2. But as it includes one dependent source, we can guess that it could be non-reciprocal. Means Y1 2, Y2 1 could be different. So I'm not saying that it is sure obvious all time that you will get non-reciprocal. But most of the cases you will get non-reciprocal, means y12 y21 will be different. So there's a high chance that the C is correct. Okay, from this logic, now we'll calculate this I1 I2 and then we'll find out all the parameters at a time, right? I hope you have got my concept. So from this pi network only, without writing any equation, we can understand that either A or C will be correct, and mostly the C will be correct, right? Now, so now we'll try to find out these equations. Now consider this node. So this is same node, no? There's no element here. So this is same node. So that I can put in that way. So this is the same node. Okay. So in this node, I1 is coming into the node. Again, 3V2 is coming into the node. Okay. So this node potential is V1. That's all. This potential, the potential across this one is with respect to ground. So I'll consider this is ground, right? So I'll use KCL at that node, input node. Okay. So if you apply KCL, Kirchhoff's current law, so what will get? The incoming current is I1 to a node plus 3V2 equals to the outgoing current. The outgoing current through this 1 ohm resistance, V1 upon 1. Okay, it's a V1 upon 1 plus the current through this branch to this side from left to right side. So this node potential is V1, this node potential is V2. So V1 minus V2 upon 1. So plus V1 minus V2 upon 1. Okay. So if you simplify it, what you will get? This I1 equals to, this is your V1, This is your V1 only. Then it is V1 minus V2. So plus V1 minus V2, and then this 3V2, it will go to the right side. Then it will become minus 3V2. Right? So if you combine this, all those things, what you'll get? I1 equals to 2V1 minus 4V2. That's simple. Now, okay, this is fine. This is equation number 1. I have got one expression for I1 in terms of V1, V2. Now second, I'll consider the node here. So this node is V2. So this incoming current is I1. Okay, and outgoing current through this one, and this one. Right? So again I'll apply KCL at node 2. Okay, so what you'll get? This incoming current is I2, that is equals to this V2 upon 1, that is the current through this one, V2 upon 1. Okay, then this current V2 minus V1 upon 1 is the current to this side, right, from this to this side. So that I'll input plus V2 minus V1 upon 1. So if you simplify it, what you'll get? So this I2 I write here only. So this is minus V1 I'll put first. Then V2 plus V2 is 2V2. Okay. So easily you can see this is your equation number 2. And so obviously the Y11 is 2. So Y11 is 2 more. Y22 is again 2 more. 2 more. This one. And this one is Y12 is minus 4. And Y21 is minus 1. So these are the parameters we can extract because just comparing with standard form. Okay, so this I1, I2, this matrix, this is simply, it is 2, it is 2, it is minus 4, it is minus 1. So you see the difference. Earlier we got 2, 2, minus 1, minus 1. Just only this is the modification. This minus 1 is becoming now minus 4. So you see this C is correct one that we guessed. No? So try to apply your common sense and solve it neatly, and you will be able to solve any problem from GATE papers. So please follow my lectures. I'll give you all the hints and try to solve these problems. Right? So this is here the solution is C. So if you like my video, please subscribe my channel. You will be getting lots of other videos. Okay, and for subscription, first press the subscription button and then press the bell icon as well. Then only you will get immediate notification of my future videos. Thanks for watching, and I hope you have subscribed my channel. And if not yet subscribed my channel, please subscribe it, and you will find many videos on this topic, two-port network and others in my channel. Please go through my channel. Thank you very much.